The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are 3 different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. So today, after we go through and answer some questions, we're going to be covering section 9.5 today. Your homework assignment tonight is 9.5 as well as the chapter review. Tomorrow, we will review for a test on Monday. So that's what's coming up. And now I'm going to go to some questions. This is a question that's actually goes back to section 9.2. And this is number 39 for an individual. And here are the directions. It says, simplify the expression if possible. Assume that the variable can be any real number and use absolute value symbols when necessary. All right, and then it says if the solution is not a real number, enter not real. So we've got a to the 6th power, all to the 1/6 power. Now, the general rule is when you have a power raised to a power, you multiply the exponents. Well, 6 times 1/6 would be 6/6, which is 1, and a to the 1 power is just plain old a. However, we're taking an even root, and we're told that the variable could be any real number. So the thing that was lacking on the answer is absolute value bars. So there you go. Now you know. All righty.
Thank you. That actually, I didn't ask that question, but that one, I was having a hard time with that one. So
yeah, okay.
Thank you.
You betcha. All right, now I am going to go to, let's see, 4765 and here and 9.3. Okay. So this is in section 9.3, and this is number 9. It says, simplify the radical expression. All variables represent positive real numbers, which means we don't need to use absolute value bars. Okay, so we have the square root of 192 a cubed b to the 5th power. The first thing I'm going to do is take 192 and break it down into its prime factors. 192 is even, and it would be 2 times 96. Okay, so now I've got 2 times, well, 96 is even, so that's 2 times 48. So that's 2 times 2 times 48 is even, so 2 times 24. So then 2 times 2 times 2 times 24 is 2 times 12, and 2 times 2 times 2 times 2 times 12 is 2 times 6. I know there's a lot of 2's here, and that's 2 times 2 times 2 times 2 times 2 times 2 times 3. Let's see, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, and times 3 is 192. What have I got there? I've got 2 to the 6th power times 3. Okay, so what I'm going to do is I'm going to rewrite the radicand as bases with powers that match the index. Recall the index is a 2 because we're taking a square root, or a multiple of the index. So 2 to the 6th power times 3 times a squared times a times b to the 4th times b. Now, 192 is right here, a to the 3rd is right there, and b to the 5th is right there. But I peeled off powers that are either 2's or multiples of 2 so that I can do the following. What is the square root of 2 to the 6th power? Two to the 6th power, the square root. It would be 2 to the 6 divided by 2 power. The square root of 2 to the 6th is 2 cubed. Do you see that?
Yes.
Okay. This is going to be stuck inside. What's the square root of a squared?
A.
What's the square root of b to the 4th power?
Squared.
B squared. And left inside is 3ab. So my final answer is 8ab squared times the square root of 3ab. Any questions on that? All right, are we good to go on to the next one?
Yes.
Okay. Here we go. This is number 18. Again, we're on section 9.3. It says simplify by combining like radicals. All right. We have the square root of 32 plus the square root of 2. In order to combine them, the quantity inside the radicals, that is the radicands, have to be identical. If I take the square root of 32 and break it down, I could write it as the square root of 16 times 2. Why would I do that? Because 16 is a perfect square. What is the square root of 16?
4.
So the 4 is on the outside. So now this becomes 4 square roots of 2 plus the square root of 2, which is 5 square roots of 2. All right with that?
Yes.
Okay. Number 23. Simplify the expression if possible. All variables represent positive real numbers. If the expression cannot be simplified, enter the given expression. We have the 4th root of, let's see if I can write that a little bit better here. The 4th root of 128 p to the 8th q cubed. So now my index is a 4. I'm going to take 128 and break it down. 128 is 2 times 64, which is 2 times 8 times 8, which is 2 times 2 times 2 times 2, 2 times 2 times 2. In other words, the 8s. So I've got what, 2 to the 7th power? Okay. Now, my index is a 4, so I want bases raised to the 4th power or to multiples of 4th powers and then leftovers. So this would be the 4th root of 2 to the 4th times 2 to the 3rd times p to the 8th times q to the 3rd. So this is a base that's a 4. Here is, excuse me, the exponent is a 4. Here the exponent is a multiple of an 8. And then the other stuff, those are going to be leftovers. So what's the 4th root of 2 to the 4th power?
2.
And that 2 is on the outside. What's the 4th root of p to the 8th power?
P squared.
Right. And what's left inside would be 2 cubed or 8q cubed. And keep in mind, they want you to multiply out like the 8 inside. Don't leave it as 2 cubed. Once you've taken everything out, you can multiply all the constant numbers back together. All right. We good to go on that one? Number 25 coming up. Simplify by combining like radicals. We have the square root of 112 plus the square root of 72 minus the square root of 63. So we're going to simplify each radical as much as possible, okay? Well, the square root of 112, let's see, 112 would be 2 times 56, which is 2 times 8 times 7, which is 2 times 2 times 2 times 2 times 7, which is 2 to the 4th times 7. Now, I know I'm going rather quickly there, but all I'm doing is breaking it down into prime factors so that I can build it back up using exponents. Now, since the index on this first one is a 2, I want my exponents to be 2s or multiples thereof. So the square root of 2 to the 4th times 7. What is the square root of 2 to the 4th?
2 to the 2nd.
Right. And then left inside is the square root of 7. So I've got 4 square roots of 7. Any questions there? All right. Let's take a look at the square root of 72. That would be what, 36 times 2? Well, 36 is a perfect square, isn't it? What's the square root of 36?
6.
So I get plus 6 square roots of 2. Oh, those aren't like radicals, are they? Well, let's
Nope.
keep going. 63, that would be 9 times 7. What's the square root of 9?
3.
So minus 3 square roots of 7. So the first one and the last one are like radicals. 4 of something minus 3 of something would be just 1 of something. And so you end up with that. And you could write it this way, or you could write it that way, either way. Now, I want to go back for a minute and look at something. I went ahead and wrote this like that because I recognized that 36 was a perfect square. If I hadn't, I could have just kept breaking it down all the way like I did over here and then see what I've got in terms of even powers. So if you can identify a square factor when you're taking square roots, great. If you can't, break it all the way down and then build it back up, so to speak.
Is it cheating that I wrote down all the perfect squares, cubes, and 4th powers?
No.
Okay. I felt kind of cheaterish.
Cheaterish?
Cheatery.
Well, no, I mean, going into a test, you shouldn't have anything ahead of time, but you could certainly, I mean, you've got a calculator, so how hard is it to write that down? You know?
Okay. Okay.
Okay.
Thank you.
You're welcome. All right, this takes us to number, let's see, 26. And it says simplify the expression if possible. The variable represents a positive real number. If the expression cannot be simplified, enter the given expression. All right, and we have the 5th root of 243 r to the 24th power. All right, so my index is a 5. So I'm looking for things raised to the 5th power or the 10th power or the 15th power, multiples of 5. 243 is 3 times 81, which is 3 times 9 times 9, which is 3 times 3 times 3 times 3 times 3, which is 3 to the 5th power. That's going to be nice. So I'm going to rewrite this as 3 to the 5th power times r to the, all right, I want my exponent on r to be a multiple of 5. And I want the largest multiple of 5 that's less than 24 or equal to 24. And that would be 20. So then I have an r to the 4th left over. Left over. There we go. All right. Again, are you seeing my strategy there? Why I'm doing that? So what's the 5th root of 3 to the 5th?
3
And where is the 3?
on the outside.
What's the 5th root of r to the 20th?
R to the 4th.
And what's left over? R to the 4th inside. So there's your final answer. All righty. Any questions yet?
Nope.
All right. Let's take a look at 27 part A. It says simplify each expression. we have the square root of 2 plus the square root of 32. Well, the square root of 32 is the square root of 16 times 2, and the square root of 16 is 4. So now we've got the square root of 2 plus 4 square roots of 2. Those are like radicals, so we get 5 square roots of 2. Okay. And with that, we're going to go on to another person's questions. Let's see here. Okay. And this is 9.3. And we're starting with number 9. Okay. This again is in section 9.3. If I do a problem with the same numbers as before and you notice that, please let me know and I won't bother to do it a second time. Anyway, we're going to start with number 9. And it says, simplify the radical expression. All variables represent positive real numbers. And we've got the square root of 192 a cubed b to the 5th. That 192 does seem.
That's exactly the
Is it?
first question that we
Okay.
did.
Okay. Then I will skip that one and we'll go on to number 10. Let's see what that one is. Simplify the radical expression. The variable represents a positive real number. We have 2 times the cube root of negative 81a cubed. All right. Negative 81 is negative 1 times 81, which is negative 1 times 9 times 9, which is negative 1 times 3 times 3 times 3 times 3, which is negative 1 times 3 to the 4th, which is negative 1 times 3 cubed times 3. Now, why did I go to all that trouble? Because again, I want powers that are 3s or multiples of 3s and leftovers. Okay, so I've got a 2 outside times the cube root of negative 1 times 3 cubed times 3 times a cubed. Now, what's negative 1 times negative 1 times negative 1?
Negative 1.
So what's the cube root of negative 1?
Negative 1.
Right. So we've got that. What's the cube root of 3 cubed?
3.
What's the cube root of a cubed?
A.
And what's left inside is just a 3. So we've got negative 6a times the cube root of 3. Okay. Questions there? Are you seeing the pattern? The nth root of a to the n equals a when a is greater than or equal to 0. So if I get this and this to match, the base comes out. If I get this to be a multiple of the index, the base still comes out, but then there's an exponent attached. Okay. All right, here's number 16. And this says simplify the expression. We've got the cube root of 64y to the 8th over the cube root of 8y squared. Now, recall, if you have a fraction under a radical, you can separate it into 2 different radicals, the radical numerator, radical denominator. Likewise, if you've got a fraction like this in the index, or is that the indices, I don't know, are the same, we could write this as a single radical. Now, why would we want to do that? Because now we can go inside and we can reduce that to 8y to the 6th. 64 over 8 is 8, and y to the 8th over y squared is y to the 6th. Okay. Well, what's the cube root of 8?
Two.
What's the cube root of y to the 6th?
Y to the second power.
And we're done. '23 coming up. All right. Simplify the expression if possible. All variables represent positive real numbers. If the expression cannot be simplified, enter the given expression. The fourth root of, I don't know, this looks vaguely familiar. Did we do this? Maybe not. Okay. All right. I think we had a 128 before. 128.
The numbers are a little different.
Just a little. Okay. 128 is 2 times 64, which is 2 times 8 times 8, which is 2 times 2 times 2 times 2, 2 times 2 times 2, which is 2 to the 7th power, which is 2 to the 4th times 2 cubed. So the fourth root of 2 to the 4th times 2 cubed times p to the 16th. 16 is a multiple of 4 times q cubed. So I've got powers of 4, multiples of 4, and leftovers. Okay. What's the fourth root of 2 to the 4th?
2.
And the 2's outside. What's the fourth root of p to the 16th?
P to the third, p cubed. Right? 4, 8. Oh, geez.
P to the 16th to the 1/4 power would be p to the 4th.
Thank you.
Okay. Left inside, fourth root of 8q cubed. Don't forget your index. Very important. Also, while I'm thinking about it, okay, an issue that people had, make sure you're using the right drop-down screen in WebAssign, because I've had people write this when they meant that. And I think to get this thing, you have to go over to the right side screen, and there's like a function menu you can drop down that has a place to put in a different index. So be careful with that. Okay. Let's see here. One more of these, 26. Simplify the expression if possible. The variable represents a positive real number. We've got the fifth root of 26. We've got the fifth root of 243 r to the 28th. 243 is 3 times 81, which is 3 times 9 times 9, which is 3 times 3 times 3 times 3 times 3, which is 3 to the 5th. Okay. R to the 28th, I'm going to write as r to the 25th times r to the 3rd, taking out the largest multiple of 5 and leftovers. Okay. What's the fifth root of 3 to the 5th?
3.
What's the fifth root of r to the 25th?
R to the 5th.
And leftover is the fifth root of r cubed. And there you have that one. Okay. So now I'm going to go back to and here. Okay. And again, I ask you, if I do a problem that's just like one from before, please let me know. We're still in 9.3. I'm going to kind of speed up the pace a little bit because I do want to have enough time to get to the new material. So this is number 18. Simplify by combining like radicals. The square root of 18 plus the square root of 2. Well, the square root of 18 is the square root of 9 times 2, which is 3 square roots of 2. So we get 3 square roots of 2 plus the square root of 2, which is 4 square roots of 2. Okay with that?
Yes.
Number 21, the cube root of 11a squared over 125 b to the 6th. I can't reduce anything inside, but I could split it up. Now, earlier we had one of these and we went the other direction. We had, like I've got at the end here, going back to the beginning, this way we're going the other direction. Now, in the numerator, I can't do anything with 11, and a squared, the exponent is smaller than a 2 or smaller than a 3, so I can't do anything there. But in the denominator, what's the cube root of 125?
Five.
What's the cube root of b to the 6th?
B to the second.
And there you go. All righty. We good to go? And here comes number 22. Simplify by combining like radicals. All variables represent positive real numbers. 10 times the 6th root of 12xy minus the 6th root of 12xy. Well, those are both simplified as much as possible, and they're like radicals. 10 of something minus 1 of something is 9 of something. So 9 times the 6th root of 12xy. And okay, that takes us to number 23. Yes, I think we've done this one. You let me know, but I think we had this same one, the 4th
It's the
root.
same, but the numbers are slightly different.
Okay,
Okay.
I'm gonna skip that one because we've done several just like that. And the person that asked for it, if you want it, still email me and I'll be happy to do it just for you. 25, we've got the square root of 63 plus the square root of 98 minus the square root of 28, simplified by combining like radicals. All right, let's see here. 63 is 9 times 7. The square root of 9 is 3, so we get 3 square roots of 7. 98 is 49 times 2. The square root of 49 is 7, so we get plus 7 square roots of 2. And 28 is 4 times 7, so we get minus 2 square roots of 7. 3 square roots of 7 minus 2 square roots of 7 is 1 square root of 7, and so we get the square root of 7 plus 7 square roots of 2. Or you could write it as 7 square roots of 2 plus the square root of 7. Either way. Okay, and finally, number 26, and then we are going to go on. This looks awfully familiar. Again, I think we did one very much like it. 243, I think, is 3 to the 5th power. So we get 3 to the 5th power times r to the 20th times r squared. So this is going to be 3 r to the 4th 5th root of r squared. And with that, we're going on to the new material with a whopping 20 minutes left. And I really need about 30 minutes. So as I'm pleading in the future, if you can come to my office hour, please do, but otherwise you can continue to request them, and that's fine with me. Okay, all right. So now we're going to look at section 9.5, which is solving radical equations. Suppose we have the following equation. The square root of x minus 10 equals 1. Actually, you know what? Let's come back to that. Let me ask you this. What's the square root of 3 times the square root of 3?
The square root of 3.
No.
3.
2 square roots
Square
of 3.
roots of 3.
So what is it?
2 square roots of 3.
So, say it again, somebody?
Is it 2 square roots of 3? Because you just add them.
No, we're not adding, we're multiplying.
Is it square root of 9?
What?
Is it just 3? No.
It's the square root of 9. It's also
Yeah.
just 3.
Yeah.
What's the square root of 7 times the square root of 7?
7.
What's the square root of 43.2 times the square root of 43.2?
I don't know.
Come on.
43.2.
43.2. Come on, folks.
Okay, yeah.
You're thinking too hard. You're thinking too hard. Okay, now, what's the square root of 3 squared?
Three?
Square root of 3. Oh,
Isn't
yeah,
that the
3.
same thing as that?
Yeah.
So what
Yeah.
is it?
3.
What's the square root of 7 squared?
7.
What's the square root of 43.2 squared?
43.2.
Okay, now let's go back to this problem. Here's what we're going to do. To get rid of the radical, we are going to square both entire sides. Okay? Now let's see if you got what we just spent the last couple minutes on. What does that give me on the left side of the equation?
X minus 10.
Yay! We have victory. And what's 1 squared?
1.
All right. So by squaring both sides, we got rid of the radical. Now we have to be careful. When we do this, sometimes we create what are called extraneous solutions. That is, solutions that don't work. So we always need to check our work, okay? All right, so now I've got x minus 10 equals 1. Add 10, x equals 11. Let's check our work. If we take that and put it right there, we're gonna get, come on screen, go back to normal here. There we go. We're gonna get that, which would be that, which would be that, so it checks, okay? So this solution worked. Any questions? Okay, let's take a look at this one. The square root of 5x minus 6 equals 2. So what are we going to do?
Square both sides.
Excellent. So we get what on the left?
5x minus 6.
And on the right?
4.
2. Oh, yeah, sorry.
Solve for x? Yeah, I know. You were thinking it was the square root of 2 squared. All right, wake up. Here we go. Here we go.
Only got 2 hours of sleep.
2 hours? How'd you manage to get so much?
Oh, yeah, I don't know. That's a lot.
I'm not even going to ask why. Okay, so if we check our work, we get 5 times 2 minus 6. We get the square root of 10 minus 6. We get the square root of 4. We get 2 equals 2. Everything checks. All right. Any questions? Moving on. Let's say we've got the square root of 3x plus 5 equals 2. Now, the first problems had a radical on one side of the equation and a bunch of stuff on the other side of the equation. Now we've got a radical term and a constant term. We want to isolate the radical term before we square both sides, okay? So what's my first move?
Would you
Take away
subtract
5.
Take away 5. Right. Now what are we going to do?
Now square it.
Yep, now square both sides. What's negative 3, the quantity squared?
negative 9? Or, no,
Negative
9.
9's inside. There you go. All right. It's those 2 hours of sleep, right? Okay.
Yeah, it really is.
All right. So now we're going to divide by 3. X equals 3. Okay. We're going to take that and check our work, plug it back into the original problem. Okay, so we came up with x equals 3 as a solution, but it didn't work. okay? I want to point something out. Let's go right back here. Before we squared both sides, we had this. 3 rules I've given you, 2 of them the first day, one of this chapter. One of them said, you can't take an even root of a negative number. Okay. The second one said, when you take an even root of a number, you can't get a negative answer. So right there, we're in trouble. We couldn't get an answer. All right. Now, what I used to do is tell people, as soon as you see that, you could say no solution. But what the authors want you to do, and I believe WebAssign wants you to do, is they want you to go on and come up with the potential answer and then check it. So this is known as an extraneous answer, and it didn't work. Some of the questions in WebAssign, they'll say, find the possible answers and then go back and tell which ones work and which ones are extraneous, okay? So you'll find them and then you'll check to see whether they work or not. All right, now, let's see here. Do any of you know the story of Noah's Ark?
Yes.
Yes.
What were the units that they used to build the ark? It wasn't feet or miles or meters.
Cubits.
Cubits.
Yeah.
Excellent. Okay, that's the answer to my next question. What are we going to do to both sides?
Cubit.
Exactly. Why are we cubing? Because we've got a cube root. Again, we've isolated the radical, but now we're going to cube both sides. So we're going to get 12m plus 4 equals 64. 4 times 4 times 4. Okay? So we can't square, I mean, we could square both sides, but it wouldn't accomplish what we need. We needed to cube both sides. So now I'm going to subtract 4. 12m equals 60. Divide by 12. M equals 5. And we're going to check our work by putting this right in there. So we've got the cube root of 12 times 5 plus 4 equals 4. The cube root of 60 plus 4 equals 4. The cube root of 64 equals 4. 4 equals 4, and it checks. Woohoo! All righty. Good to go on? Excellent. Let's see here. We have, okay. It says let f of x equal the cube root of 3x minus 6. For what value of x is f of x equal to -3. Now, this is another thing where the author, I think, is just trying to get used to function notation. Basically, we're going to substitute. We're going to take this, whoops, and put it right there. So what our equation becomes is the cube root of 3x minus 6 equals -3. Okay? You see how I got there? Once again, Noah's Ark will rescue us. We're going to cube it both sides. 3x minus 6 equals -27. Add 6 to both sides. 3x equals -21. Divide by 3, x equals -7. We're going to take that and we're going to check it right here. So going back to our original, before we cubed both sides, the cube root of 3 times -7 minus 6 equals -3. Sorry, I paused there because I'm going, wait a minute, is that right? But yes, it is. Sorry. The cube root of -27 equals -3. It's because my brain was saying -28. I'm going, wait, that's not going to work. Cube root of -27, -3 equals -3. It checks. And I got more than 2 hours sleep, so I don't have an excuse. I'm just old. That's my excuse. It's my excuse for everything. I'm just too old. All right. Now, let's see here. Now we've got a situation where we've got two radicals. We've got one on both sides of the equation. So m plus 4 square root equals 2m minus 5. So if we have one radical, we want to isolate it completely. If we have two radicals, we want to separate them. Let's see. I'm trying to remember. Did we already do absolute value equations? Or is that coming up later?
On this section?
No,
Or-
just period. Did we already?
Yeah,
do
we
that?
did.
We did, yeah. So remember in absolute value equations, we isolated the absolute value if there was just one. And then if we had two of them, we separated them. Same thing with radical expressions. If you got one separated, you got two, excuse me, you've got one isolated. If you have two, separate them. These are already separated. So now what are we going to do?
Are you going to square it?
We're going to square both sides. Yes. So m plus 4 equals 2m minus 5. All right. I'm going to solve for m on the right. So I subtracted m from both sides, added 5 to both sides, m equals 9. Let's see if that works. Now, off the top of my head, I don't know what the square root of 13 is, but would you agree that the square root of 13 equals the square root of 13?
No, I'm just kidding. Yes.
Okay, good. All right, now let's take a look at some formulas. Let's say we've got this. D equals 1.4 square roots of h. It says solve each equation for the specified variable or expression, and we are supposed to solve for h. Now, in our final answer, we just want plain old h all by itself. So there's two things we've got to get rid of on the right side. We've got to get rid of the 1.4, and we've got to get rid of the square root of h, excuse me, the square root part of it. So we can either square both sides now, or we can divide both sides by 1.4 and then square both sides. It won't matter. Which would you like to do?
Seems like squaring them first seems easier.
Okay, then that's what we'll do. Now be careful. I don't get 1.4h. I get 1.96h. Where did I get the 1.96? Because
1.4 being squared.
right, because you're let's see here. You're applying the 2 to the 1.4 and to the square root of h. Now what are we going to do?
Take
What
away
did
the
Moses
1.9.
what did Moses do to the Red Sea?
Cubit.
No.
Oh.
He divided it.
Sorry.
Cubit. Come on now, that was Noah. All right. So d squared over 1.96, and there you have it. Those Egyptians could have used the Noah's boat there to, well, whatever. Okay, sorry, different time in history. You okay with this?
That one was difficult.
Was it? Okay.
But it made sense. It made sense though. The part that got me was that you were taking the square root of h and basically turning it into division. Is that what I understand?
No. We took, okay, let's go back here. Let's see, what was it? 1.4 square roots of h. Okay. We're squaring both sides. Okay.
Right.
So I've got d squared equals 1.4 squared, the square root of h squared. Because if I have a product raised to a power. You attach that power to each
Throughout.
factor.
Right.
So now I've got d squared equals 1.96h.
Okay, so to end up with the 1.96, then you divide to get it to the other side.
Right.
Okay,
Okay.
that's
So,
where that came in.
Anthony, is that your radio going on in the background there?
It's actually my child is doing their school too.
Oh, okay.
Sorry about that.
That's okay. Can you mute yourself except when you're going to talk? When you're going to talk, we certainly want to hear you, but thank you so much.
Right. Sorry about that.
That's okay. That's okay. We can deal with things such as that. All right. D equals the cube root of 12v over pi, and we're supposed to solve for v. Okay. Now, what are we going to do to both sides? We're back to Noah.
Cube it.
There you go. Good job. So now I've got d cubed equals 12v over pi. All right. What do I need to get rid of still on the right side?
The pi?
Pi, okay. So we'll multiply both sides by pi. So pi d cubed equals 12v. What else do we need to get rid of?
The v?
And we're trying to solve for v.
Oh, 4v, 12.
12, there you go. See, it's as easy as pi. V equals pi d cubed over 12. There you have it, folks. You heard it here first, or maybe you didn't, but all right. I will be back at 1:15 this afternoon with my office hour, should you have need of me. Or if you can't make that and you still have questions, email me and I will try my best to reach out to you. Again, today you're going to wrap up this chapter, section 9.5, as well as the chapter review. Have a great rest of the day, and I will stop the recording.